So in this video, I'm going to show you how to factor a quadratic expression when a is not equal to 1. This is different than factoring a quadratic, of course, when a is equal to 1, because we can't simply find numbers that add to b and multiply to c and then skip right to our factors. Right? So when a is not equal to 1, as we see in this case here, right, a is equal to 3, we have to start by finding numbers that add to b and multiply to ac. So in this case here, we know that it's in the form ax squared plus bx plus c. So in this case here, a is equal to 3, b is equal to a -5, and c, of course, is equal to -2. So we have to find numbers that are going to add to -5 and multiply to 3 times -2. So blank plus blank is equal to a -5, and blank times blank is going to equal 3 times -2 is -6. So the numbers that are going to add to -5 but multiply to -6 are going to be -6 and +1. -6 plus +1 is -5. -6 times +1 is going to equal -6. So what we need to do with those numbers now, the -6 and the +1, is we need to be able to split up this middle term, the -5x. So that's going to become -6x plus 1x. And we'll still keep the -2 on this end, and we'll still have the 3x squared on that end. Now, of course, the order here, the -6x plus +x, doesn't matter. You could have switched those around and you still get the same result at the end. But the reason we do that is we want to be able to create 4 terms so that we can group the first 2 terms together and then group the second 2 terms together and then pull out greatest common factor from each. So from the first set of parentheses here, we're going to pull out a 3x. So that gives us 3x times, and then if I pull a 3x out of the 3x squared right there, we're going to be left with x. And if I do a -6x divided by 3x, we're simply going to get -2. All right. In this other set of parentheses over here, the only thing we can pull out is a +1. And of course, if we do that, then nothing inside the parentheses is going to change. So we end up with 3x times x minus 2 plus 1 times x minus 2. Now, here's the first place where I get to check to make sure that I'm doing everything correctly. If I did everything right, then both sets of parentheses should be exactly the same. If they're not, then I must have made a mistake somewhere along the way. So now what ends up happening is these 2 sets of parentheses, the x minus 2's, those are now the greatest common factor. So I have one term here, 3 times x minus 2, and I have another term here, 1 times x minus 2, but they have x minus 2 in common. So we're going to go with x minus 2, and then whatever's left over on the outside is just going to be that 3x plus 1. That becomes my second factor. All right, so there I am. I've factored 3x squared minus 5x minus 2. And if it equaled 0, so let's pretend at the beginning right now, this had equaled 0, that means all of these steps all the way through would have equaled 0. And now I would have to go ahead and use the zero product property to show that, okay, if x minus 2 equals 0, that means that x equals 0. Oh, sorry, x equals +2. Or that if 3x plus 1 equals 0, then 3x would equal a -1, or x would equal a -1/3. So those would be the zeros, or the solutions to that equation. And if I wanted to check my work to make sure that I factored everything correctly, the most straightforward way would be to distribute or FOIL the factors I have over here. So if I have x minus 2 times 3x plus 1, if I multiply those back together using the distributive property, I should end up with this expression that we had over here. So let's start by distributing the x, and that's going to give us x times 3x is 3x squared. X times positive 1 is going to be plus positive x. And then we take the negative 2 and we distribute it there and there. And that should give us negative 2 times positive 3x would be minus 6x. Negative 2 times positive 1 is a negative 2. And if we combine our like terms, we get 3x squared minus 5x minus 2. So we can now see that our solution here came out to be the exact same thing we started with here. So the factored form would end up being this part right here, and where these would be my solutions if I was given an equation at the beginning. Okay? Good luck, and thanks for watching.